Today, we're gonna do U-Substitution. It's quiz day, so D12 quiz 10 due tonight, handwritten quiz 9 is open today. We're gonna talk about U-Substitution. So last week we talked about antiderivatives, and we talked about the fact that we can only do antiderivatives if we had added or subtracted terms together. There was nothing like a product rule, there was nothing like a quotient rule, only if we had a bunch of things added or subtracted together. Today, what we're gonna do is sort of find antiderivatives of chain rules. So you remember we have the chain rule for derivatives. If you have a derivative of something, you can do the derivative of the outside times the derivative of the inside. We would like to be able to undo that when it's obvious that it's a chain rule. And that's what U-Substitution does for you. It undoes the chain rule. So the chain rule says that the derivative of g of f of x is g prime of f of x times f prime of x. Yeah. If I'm going to undo something that looks like g prime of f of x times f prime of x, it should undo the chain rule and give me g of f of x, right? So my procedures for how I do a U-Substitution is I have to figure out what the outside function is. I have to make sure that the derivative of the outside function is there. And then I have to find the antiderivative, okay? So procedures of U-Substitution. They sort of go pick the U. That's the inside function. The U is going to be the inside function. And then find the derivative of U. Because remember, this guy is my U, the inside function. And this guy is my du, the derivative of that. Okay, so then I substitute, hence the U-Substitution, for U and du, and find the antiderivative. Substitute for u and du. So I'm going to substitute back in. So I'm going to start with an integral that has a bunch of x's in it. I'm going to pick an inside function. I'm going to find the derivative of that inside function. I'm going to substitute it in. That's going to have a u and a du now. So instead of having a bunch of x's and dx's, I'm going to rewrite it as something that has u's and du's. Hopefully, when I do that rewriting, the integral or the antiderivative is easier to find. So it's going to fit one of my rules then.
Doesn't that say substitute u?
Substitute for u and du. Du is like the derivative of u. Oh yeah, this one says find the derivative of u. It's terrible handwriting today, right? I think it's when I try to write inside the boxes, it like doesn't like it. I got that iPad Pro, you know, except I don't know how to connect it to the projector and or to my computer. I think if I got like a, but then, so then my question is, how do I, because you know, like on Fridays, I screenshot Infinity questions and put them in the Word document, right?
Speaking of Infinity, which questions will this help us answer?
At the end of today, you'll be able to do all of them.
Okay.
We're going to do more practice on Wednesday with some of the harder ones. But at the end of today, you'll know everything you need to do all of them. Okay, so here are some tips. When you're thinking about what your inside function should be, you think about it as things like things raised to a power, things under a square root, things in the denominator, things inside a sine or cosine, right? You want to think about your inside function being that kind of stuff, right? So if I start with this first antiderivative here, 3x minus 4 to the 5th dx, what would you pick as your inside function u?
3x minus 4.
3x minus 4. Yeah, so my inside function u is this 3x minus 4. So my step said 1, pick my u. 2, take the derivative of that function, right? So ignore what's in your function, in your integral now, and take the derivative of that u that you picked. So what's the derivative of 3x minus 4? 3 dx. Yeah. Okay, there are two schools of thought on what you do next. I don't care which one you choose. I'm always going to do the one that doesn't mix U's and X's together, but you might like it better the other way. So, but I'm going to do the one that doesn't mix U's and X's together. Okay, in this antiderivative, I need U, 3x minus 4, and I need du, 3dx. Do I have this 3dx? What do I have left here?
Times dx.
Just the dx, right? So I need to stick a 3 in there. If I'm going to stick a 3 in there, how do I undo a multiplying by 3? You divide by 3. So if I stick a 3 on the inside, I'm going to put a 1/3 in the front. So I needed it to be 3dx, so I stuck the 3 in there. I can't stick a 3 in there without changing it. So to undo that, I put the 1/3 in the front. 1/3 times 3 makes 1. When you multiply by 1, you don't change anything. So the 3 and the 1/3 essentially don't have to exist, right? But now I have u to the 5th times du. So now my integral looks like u here to the 5th times du. So 1/3, because he's in the front, u to the 5th du. Can you take the antiderivative of that? Of 1/3 u to the 5th?
U6 over 6.
Yeah. 1/3 times antiderivative of something to the 5th is add 1 to the power, divide by the new power, plus c. Good. Okay, the equation that I started with had x's in it, right? So in the end, my answer should have x's in it. How do I make this guy have x's? Yeah, u is 3x minus 4. So here, instead of writing 3x minus 4, I'm sorry, instead of writing u, I'm going to write 3x minus 4. So can I combine these? 1 over 18, 3x minus 4 to the 5th plus c. Sorry, what?
To the 6.
6.
To simplify it.
No, you don't. You don't have to simplify, but you have to make your answer have x's instead of u's. So you can't stop at this point. You have to put the u back in so that you have x's in there. But you could leave it as 1/3 times 3x minus 4 to the 6th over 6 plus c. Okay, I gotta scroll back up because my problem's up here. Okay, 3x squared times x cubed plus 4 to the 5th. What would you pick as the inside function here?
That's x to the 3rd plus 4.
Yeah, the x to the 3rd plus 4. So remember your inside functions, stuff raised to powers, stuff in square roots, stuff in the denominator, stuff inside sines and cosines. Those are the inside pieces. So in this one, my u is going to be up. I was looking at that problem before. X cubed plus 4. So this guy here is my u. Okay, what is the derivative of x cubed plus 4? Remember, you ignore now what's in your integral. You look at this function and you use your derivative rules. What's the derivative of x cubed plus 4? 3x squared. 3x squared dx. Do I have that in my integral? Yeah, look, 3x squared dx. So I don't need to do any of that sticking stuff in, right? I already have everything I need. What kind of things can you stick into the integral? Do you think you can stick an x in? No. The only things you can stick into the integral are numbers. If you find your du and you're missing something other than a number, you made a mistake, okay? Either you can't use U-substitution or you picked a wrong u. So when you find your du, if you're missing something other than just a number, like over here, we were missing the 3, right? If you're missing something other than just a number, bad. Okay, so I picked my u, I found my du, I'm gonna rewrite this, whoops. This looks like u to the 5th du, right? The yellow stuff was u. I had that power of 5 there. He didn't go away, that power of 5. And then the blue stuff all knit together into du. Okay, now I have to take the antiderivative. Don't forget to take the antiderivative, right? So what's the antiderivative of u to the 5th? U to the 6 over 6 plus c. Okay, can I end like that? No, if I have x's when I start, I need x's when I end. So how am I gonna write that, guys? Perfect.
So might have said this, but we don't put 3x squared in front because it cancels out.
We don't need the 3x squared in front because this guy already had the 3x squared. Yeah, it cancels out with the du. It smushes together with the du.
Should it be a 6 to the power of 6?
Yeah.
Write down that step anyways, just so I don't forget it.
Yeah, sometimes what you might want to do is rewrite it so that they're together. Yeah, you could put the 3x squared and the dx together at the end, because then you know, oh, that whole thing together went into my du. You have time. We're gonna do a quizzes now. It's Nabil's chance to get a sticker. We're gonna get there.
Quick question.
Yes, sir.
Hold on, I need to find it.
Okay.
When we were dealing with y related rates.
Okay.
You're gonna have to worry about related rates with intervals and antiderivatives.
Nope. Nope. No more word problems.
Oh, no.
Oh,
it
that's not
wasn't
true.
related rates, it was,
Implicit differentiation.
yeah, I think that.
You want to do it together? I don't. Joinmyquiz.com 729-622.
It was the stuff when you had to get dy or dx on one side of the equation.
No, we don't have to do that.
Okay,
Joinmyquiz.com 729-6. My stickers out, and I have to replenish my stickers. Oh, I'm gonna pause the recording. Someone needs to be the job. Recording, huh? Yes, thank you. You should get a sticker for that. I'll get you one right before we end. Okay, sine of 5x minus 2. Sine of 5x minus 2. What are you gonna pick for your u if you're doing sine of 5x minus 2?
5x minus
5x minus 2, yeah, I like that. 5x minus 2. What are you gonna pick for u in the next one? Yeah, in the next one, you're gonna pick u as 7x minus 3. Yeah, so we pick u's as inside powers, inside square roots, denominators, inside sines, cosines, tangents, and exponentials. Okay, what's the derivative of 5x minus 2? 5 dx. Okay, so this guy needs a 5 in there. If I stick a 5 in there, what do I have to put at the front? A 1/5. So I have 1/5 sine of u du. What's the antiderivative of sine? Negative cosine, right? So negative 1/5 cosine of u plus c. I started with x's, so I should end with x's. What's going to go in there? 5x minus 2. Perfect. Okay, I picked my u to be 7x minus 3. Yeah? What's the derivative of 7x minus 3? 7. 7 dx. Okay, so I need a 7 in here. If I put a 7 in there, I have to put a 1/7 in the front. Perfect. So I have 1/7, 1 over u du. Remember, this whole 7 dx is my du, right? Same here. This whole 5 dx was my du.
So that's an
Yeah, that's an ln u. Perfect. Okay, I started with x's. I should end with x's. 7x minus 3 plus c. Okay, we're gonna up our game a little bit. With 2 more. Let's just pick our u's. So let's not do the whole thing yet. Let's just pick our u's. So for the first one, what are you gonna pick your u? 4x minus 5, right? Stuff inside a power, stuff underneath the square root, stuff in the denominator. So in my first one, I'm gonna pick my u to be 4x minus 5. How about for the second one? What do you think your u is gonna be in the second one? Yeah, there's a power there, right? You got that 2. This one's tricky because it has powers and it has square roots. Powers always come first. If you have a whole bunch of stuff to a power, the whole bunch of stuff should be your u.
The u is the square root of x minus 1.
The u is going to be the square root of x minus 1. The u is going to be the square root of x minus 1. So when I talk about picking u's and du's, I try to say them in that order. The powers always beat out denominators, okay? So powers beat out denominators. So powers, square roots, denominators, sines, cosines, exponentials. Powers, square roots, denominators, sines, cosines, exponentials. Okay, so now we've picked u. I want you all to find what du is going to be. So for both of these, just find du. You don't have to do any more than that. Just find du. So we picked u. Find yourself du. The first one's easy.
I'm confused with going back and forth.
I know, right? You have to be very particular about like taking the derivative, right? E means derivative, go down. Like that. What's the derivative of square root x minus 1?
1/2 x negative 1/2.
1/2 x to the negative 1/2.
So we're supposed
right?
to, we just put 1/2 into the function.
Let's see. 1/2 x to the negative 1/2. Okay, I'm going to rewrite this guy. I'm going to rewrite this guy as square root of x minus 1 squared times, what is this? Square root of x in the denominator?
X to the negative 1/2.
X to the negative 1/2 dx. Yes? Okay. The stuff inside here is my u. That was my yellow one, right? The stuff inside the square is my u, this yellow one here. That's my u. I need du. I need this stuff. What am I missing? 1/2. If I put 1/2 inside here, what do I put at the front? 2. If I put 1/2 inside there, I put 2 at the front. Okay? So now all of this blue stuff at the end, 1/2 x to the negative 1/2 is my du. The yellow stuff in there. So this guy looks like 2u squared du. This guy looks like what? How are you going to rewrite this first guy? Oh, I don't have it. What am I missing in here? 4. Yeah, I'm missing a 4. If I put a 4 inside, then I need a 1/4 in the front. Perfect. I'm missing that 4. Okay, so I have 1/4. What goes here? Square root of u, yeah. So 1/4 u to the 1/2 du. Okay, now you have them like that. Take the antiderivatives. Take a second to take the antiderivatives. When you take the antiderivatives, the exponent should go up. Add 1 to the power, antiderivative add. Add 1 to the power, divide by the new power. The right-hand side is easy, right? Let's do that one first. Add 1 to the power makes it cubed divided by 3 plus c. I started with x's, so I should end with x's. Square root of x minus 1 cubed plus c. Okay, the left one, 1/4, add 1 to the power. 3/2. Yeah, add 1 to the power makes 3/2. Dividing by 3/2. Yeah. So you can do this 2 ways, right? You can do 1/4 divided by 3/2, get that constant, right? Or you can remember that this flips over, right? 1/4 times 2/3. Either of those is okay. In the end, we get 1/6. U, what was u? I forgot. 4x minus 5 to the 3/2 plus c. I mean, it's not as much work as optimization, the product rule or the quotient rule, right? You just forgot how much work we used to do.
You prefer when you got call it u squared.
Yeah. So the derivative of square root of x minus 1 is 1/2 x to the negative 1/2. I needed this guy to have a 1/2 in here because I just had the x to the negative 1/2. So remember, I can stick in a constant as many times as I want. So I needed a 1/2 in here. If you put a 1/2 on the inside, to undo that, you put a 2 on the outside because 2 times 1/2 makes 1. So I have 2 on the outside. This is my u squared. And then that whole thing at the end, the 1/2 x to the negative 1/2 dx is my du. So 2u squared du. See you later. Don't forget it's quiz day. I said that already. Just remember it's quiz day. I started, yeah. Matthew reminded me.